Okay. Here we go. Look at this sheet first. This one. There we go. We got to review. See what you guys remember. This sheet is your lifeline for your test. I will give this to you for the test. I will also give you another sheet of paper, which is much more confusing and has like 50 or 80 formulas on it. This one doesn't have very many. Let's start here. Do you know that tangent is sine over cosine? Are we all good there? Do you know that tangent is 1 over cotangent? Okay. If you need one of these explained, you raise your hand and I will show. Cosecant is 1 over sine. And sine is 1 over cosecant. Good there. Secant is 1 over cosine, and cosine is 1 over secant. And cotangent is cosine over sine, and cotangent is 1 over tangent. We all good with all those? Okay. Then we go to our fundamental identity, which is sine squared plus cosine squared is 1. You remember that from covering a while ago. This is what you're going to have to know for your ACT test on Saturday. Raise your hand if you're taking it on Saturday. All right, go ace it. All right, and then take it again in June. So, sine squared plus cosine squared is 1. 1. You got that in your brain? Now, from here, watch this. This is a really important part. I could change this formula like so. I could subtract a sine squared of x from both sides. You don't have to write this down. You can just watch. But I get cosine squared of x is equal to 1 minus sine squared of x. Would you agree? So that's the same as that. It's just rewritten differently. Now, I put that example right here. So I put all sorts of different ways to rewrite these problems. Here's another thing I write, is that 1 minus sine squared is the difference of two squares. So I can rewrite that as 1 minus sine of x and 1 plus sine of x. Now, question that came up second hour was this. Sine squared of x. That is the same thing as sine of x quantity squared. It's like you're squaring the whole thing, which is the same as, say, sine of x. You know, even if you don't write the parentheses around the x squared. But it's not the same as this, sine of x squared. That is different from the others. Does everybody understand that? Okay, so do you now see, as I put this sheet together, all the different ways that you can rewrite that formula? What if I go like this? What if I take this formula right here and I divide everything by cosine squared? What's sine squared divided by cosine squared? What's sine divided by cosine? So this gives me tangent squared. What's cosine squared divided by cosine squared? 1. Right there. What's 1 over cosine squared? Secant squared. So I could take this and divide through by cosine squared to get that, which then gives me a whole nother set of these. And if I divide through by, instead of cosine squared, if I divide through by sine squared, then I get the bottom one and I get all this. And that's where everything comes from. Good. Let's try. Problem number 1. Oh, goody, goody. Thank you, Mr. Gens, for writing up so many examples, because I learn from examples. Examples are good for me. Good for my brain. Food for my brain. Feed my brain. We got to simplify these. You will never use this in real life. Never. Then why do we do it, Mr. Gens? Why do you do push-ups in football practice? You never do push-ups in a football game. You do it because it makes you stronger, right? It's push-ups for your brain. Push-ups for your brain. My brain doesn't need this. I want a brain like a jar of mayonnaise that just tastes good. What? Yeah, whatever. So we want to simplify some of this stuff. We want to use relationships that we've seen on the other page. You will use this in order to cover more mathematics in the future. But right now, all we want to do is just reduce it. So one method for reducing is to rewrite in terms of sine and cosine. And I'm going to tell you right now that we're like the whole first 2 pages is just easy problems. You're going to have hard problems on your test. So this is just building blocks. Not too many easy ones. So sine of theta is just sine of theta over 1. How do I rewrite secant in terms of sine or cosine? 1 over cosine of theta. Okay, now I can rewrite that as sine of theta divided by cosine of theta. Is everybody with me so far? What is sine over cosine? Tangent. A for the day. So sine times secant is really just tangent. You simplified it. Way to go. Cotangent times sine. I rewrite cotangent to be cosine of theta over sine of theta. I rewrite sine of theta as sine of theta over uno. That's Spanish for 1. All right. What happens? Cross out the signs. What's left? Cosine of theta. Wow, Mr. Gens, you're making this really easy. It's connecting with my brain and my learning. I'm becoming smarter by the second. Yeah, my brain's doing push-ups. Okay. How about this one? Secant is 1 over what? Cosine of theta times 1 over sine of theta. Now, does sine times cosine give you anything special? No. I mean, if you were to rewrite this, it would just be 1 over sine of theta cosine of theta. That doesn't really do anything for us. So this isn't really any more simplistic than the beginning. So sometimes you realize after a while that there may not be a way to really reduce an identity. You may just have to simply leave it like it is. And you just got to know when that time comes. So what I want you to do is D through F. D, E, and F, and I want you to try to reduce those identities down to its good form. When you think you get one, you can come and put it up on the board. You can use whichever color marker you want even. Okay, let's check that letter F. So you got 1 over cosine, because that's secant, times 1 over sine, that's cosecant, times cotangent is cosine over sine. Do you see now that cosines will cancel? Great. So that leaves you with 1 over sine squared, and that's in the denominator, which will then be the same as cosecant squared of theta. So yeah, the squared goes after the trig function. So whether you got sine, cosine, or tangent. So, okay. Let's try another one. Tangent over secant. Now we rewrite it as sine of theta over cosine of theta over secant would be 1 over cosine of theta. Wow. Holy cow. So I cross off the bottom and multiply by the cosine of theta over 1. The cosines cancel, leaves you with... It's actually kind of fun, isn't it? Whatever. Tyler! Because I let you go to band every day, you should be a little bit more grateful in your response. Cosecant can be rewritten as 1 over cosine. Sine of theta divided by cotangent is cosine of theta divided by sine of theta. Multiply by the Reciprocal. You are allowed to make noises when you cross stuff off. Sines cancel. Leaves you with 1 over cosine of theta, which is? Being I'm the coach, maybe I should go, huh? Yeah. No, it's at Austin. Trent, I don't think she's very nice. All right. Question? Nope. Okay. Everybody see how I got secant? Any questions? Okay. Next one. Sine over 1 times 1 over cosine divided by, what's tangent? Sine over cosine. Oh, hey, what do you notice? Yeah, you're going to have sine over cosine divided by sine over cosine. Then you're going to get what? Whoa. Okay, you try J and K on your own since you're so smart. When you get the answer, come put it up on the board. Show me what you got. Yeah, you guys should totally sign up. Oh, Tara. All right, very good. So tangent squared and cosine, absolutely correct. Any questions how they got that? Okay. Oh, today, Junior. What movie? What movie? Billy Madison, thank you. I said Schnikes earlier today, and everybody was like, what is that? Tommy Boy? Yeah, exactly. You've never seen Tommy Boy. Best movie ever. All right. Okay, here's where I lost everybody second hour. And they saw 1 minus cosine squared. Don't write this down. Okay, don't write this down. But sometimes people will take this route, and they will distribute the cosecant through. And they'll get cosecant of theta minus cosecant of theta times cosine squared of theta. And then after they do that, they'll switch it around, and they'll say, well, that's 1 over sine minus 1 over sine times cosine squared over 1. And then I could, like, put one of the cosines there. So make that a cosine, that a cosine. So that would be, like, 1 over sine time or minus, let's see, that would be cotangent, cosine. Yeah, you're lost, right? Okay, so there are different avenues to some of these problems. It requires foresight on your part. Foresight on your part to be able to identify the best approach. The best approach is to do this. Aim for the day. What's 1 minus cosine squared? Very good. Casey Gilbertson, where did you see that? Yep. Anytime you see a 1 and something squared, there's a good chance that it might be on this sheet right here. And as she looks, she sees this number 5. 1 minus cosine squared is sine squared. Okay? And so that's really, really important. So if we go back to the sheet, therefore we have sine squared times cosecant. Now you can simplify some of this. You got sine squared of theta over 1 times 1 over sine of theta. How many sines will cancel? 1, leaving you with sine of theta. Secant squared minus 1. What can I put in for that? Good, times tangent squared. Let's get rid of our tangent squared and rewrite it as cosine squared times sine squared over cosine squared. And if I multiply, what cancels? And I'm left with secant squared of theta minus 1. Oh, yeah. Yeah, we just answered that. That's tangent squared. Well, now I do the same thing that we did on the front page. Sine squared theta divided by cosine squared of theta divided by sine squared of theta over 1. I have broad shoulders. I can't help it. Multiply by the reciprocal. Sine squareds cancel, leaves you with 1 over. What's 1 over cosine squared? What about O? No. You can't take tangent squared and subtract tangent squared. You got to use order of operations. Can't do that. And if you switch this to sine squared over cosine squared, you end up getting sine to the 4th on top. That doesn't really help us out at all. You got nothing. Nope. Okay. Starts with F, rhymes with actor. Now, every year, somebody in the class has a question of how I came up with that from the previous one. Is anybody wondering that? Okay, so this is like x minus, or x squared minus x squared times y squared. And if you factor that, if you take out an x squared, you would have 1 minus y squared, right? It's the same thing. You have to tell me if it makes sense or not, because I don't know why it doesn't make sense the first way I wrote it. It's the same thing. Too many letters. Okay. What do you do in English? Holy cow. All right. All right. So everybody got that? Okay. What can I put in for 1 minus sine squared now? So I can put in cosine squared. So that means I have tangent squared times cosine squared. What should I do now? Sine squared of theta over cosine squared of theta times cosine squared of theta over 1. What cancels? Leaves you with sine squared of theta. Yeah. Okay, how about P? What do you want to do there? So I take out a sine squared. And what are you left with? Secant squared minus 1. What's secant squared? Minus 1. Tangent squared. So I can rewrite this as sine squared over 1 times tangent squared is sine squared over cosine squared. Does anything cancel? No. So in this situation, you don't come up with anything really nice. You're just going to have to leave it as sine squared of theta times tangent squared of theta. And we'll just leave it like that. What do you think? Let's go do 3 more here. Any questions on P? Okay, Q. What do you want to take out? Cosine squared times 1 plus tangent squared. What's 1 plus tangent squared? Secant squared. So what you end up with is, very good. Do you need this? All right, I'll recycle it. So you got cosine squared times secant squared. Those are reciprocals of one another, right? What happens if you multiply reciprocals of one another? You get 1. Yep, gotta know that sheet. And a lot of people are like, okay, you know, yes, I'll use that sheet on the test. The more you can get that sheet built into your brain, the better off you'll be. Trust me. Trust me. And it'll happen. Okay, so simplify the following expression, slightly more difficult. So these are kind of like, we just got done with level 1 problems. Those are kind of like level 1 problems, okay? So these are a little bit hard. These are like level 2 problems. So we got tangent squared over secant of theta minus 1. Now, what's different about this type of problem is that you don't have anything squared in the bottom. If it was secant squared minus 1, then you could insert a tangent squared. But that's not the case. So I'm going to look for the secant of theta minus 1. If I look on my sheet, I can see that I have a secant of theta minus 1 right here. Do you see that? So, if I can come up with a secant squared minus 1 somewhere, then I can use that piece. Well, secant squared minus 1 is the same as tangent squared. So watch this trick. I think you guys will like this. When you see this kind of a problem, you actually want to insert something for the top. You get secant squared of theta minus 1. Trenton. Almost like you're too smart for this. Can't cross anything off because you can't divide off terms. So what we want to do here is we want to factor that. Secant squared minus 1 is secant minus 1 times secant plus 1. Right? It's the difference of 2 squares. Yeah? So in the bottom, you have secant minus 1. So what can you do now? And you only have, then, secant of theta plus 1. Last one, same type of situation, except you got sine squared on the bottom. What should I put in there? Good, 1 minus cosine squared of theta. And I'm going to do that because I know that that factors as the difference of 2 squares. So that's equal to cosine of theta plus 1 over 1 plus cosine of theta times 1 minus cosine of theta. Does everybody see how that does factor the difference of 2 squares? It's on your sheet, but it's also the difference of 2 squares. Now, cosine of theta plus 1 and 1 plus cosine of theta, are those the same? Yes, they are. Why? Because addition is commutative. Very good. Very switchable. Addition is switchable. That's what we'll It is. I'm not laughing at you. I'm only laughing because Jesse and Tyler were laughing. There you go. 1 over 1 minus cosine theta. Bada bing, bada bam, bada booski. Oh. All right, so tomorrow we'll finish up those, and you'll have a nice, super long assignment. No, but tomorrow you have so much homework. Good luck, everybody.